Hey guys, my name is Trevor Sullivan. I'm a solutions architect with StratusGrid, and I'm also an AWS ambassador. StratusGrid is an AWS premier partner, and we're also an independent software vendor. We have a software as a service platform called Stratosphere, which is a FinOps solution that allows you to report across your cloud spend across all of your different AWS organizations and Azure environments. And it also helps you to identify cost savings opportunities. So you can actually purchase Stratosphere through the AWS Marketplace as well. So we are listed on there. And in the Stratosphere console UI, you have a few different views here that help you to identify your spend opportunities or cost savings opportunities, rather. You can see which region those savings are in. You can see which AWS account ID it's in based off the resource ARN. You can also filter by the specific type of finding that you are looking for. So if you're looking for load balancers specifically, you can check that off. Or if you're looking for idle RDS instances, you can filter down to that. So there's a lot of customization in here that allows you to find ways to optimize your spend. There's also a financial analysis reporting view here. And what this allows you to do is to report on your spend across specific services or across different AWS accounts. You can save those filters for future reference so that you can look at your spend over a period of time. Maybe you want to look at it every month and just kind of look back on what you're spending on production accounts or what you're spending on QA accounts or that kind of thing, or even on specific services. So this allows you to see your spend breakdown across your entire cloud environment. You can also filter to AWS or Azure spend specifically, or to specific services that you are interested in seeing here. And then we also break down your discounts here. So if you have a compute savings plan, we'll show that application here. If you have a preferred pricing agreement or private pricing agreement, that'll show up as a line item as well. And if you have any potential savings, we actually break down that into low hanging fruit, medium, and high effort items as well. And so you can track your potential savings over time, starting from the date that you actually onboard your cloud environments to Stratosphere. So if you're interested in checking out Stratosphere, feel free to go over to our website at stratusgrid.com and hit book a demo, and we would love to walk you through it. So the topic for today's video is going to be on cost optimization using what are called Amazon S3 lifecycle rules. Now, Amazon S3 is a general purpose storage service. It just allows you to upload arbitrary data as objects into a bucket. And S3 buckets have a flat data structure. So you basically just have this bucket, and you can have millions and millions or billions of different keys or files, you can think of them like, inside of the S3 bucket. Now, over time, depending on how your applications are storing data in S3, you may find that you are just accumulating massive amounts of data over a long period of time. And you may not necessarily have a specific requirement to maintain that entire log of historical data. So if your business requirements state that you only need to maintain maybe 24 months of data backups if you're using S3 for storage backups, for example, then you might want to trim out any data that's older than 24 months. And by default, S3 buckets are not configured with any kind of lifecycle policies in there. So it will just continue to accumulate data unless you actually go in there and manually clear out those old objects that you no longer need, or if you go in and actually enable the lifecycle rules feature. So that's what we're going to be talking about today. Now, there's a couple of different actions that can be performed as part of lifecycle rules. There's what are called transition actions, and this allows you to take an S3 object and move it from the standard storage tier in S3, which is the most costly form of S3 storage, and then you can move it to a less expensive version of S3, like infrequent access or Glacier. There's several different pricing options available for S3. And if you just do a quick search for S3 pricing here, this page should kind of walk us through what the different storage tiers are. So there is standard infrequent access. That's kind of a step down. There's also S3 One Zone. There's S3 Glacier with instant retrieval. There's Deep Archive as well. So there's a bunch of different options that you have as far as, the pricing tier that you want For data that is not frequently accessed, infrequent access will cut your storage costs by a fair amount. But if you have data that is really large, that you know that you're not going to need to access except for an absolute worst case scenario, then you might want to look at using S3 Glacier, because that is going to reduce the per gigabyte storage cost even more, with the caveat that you will pay a higher data retrieval fee if you do need to pull that data out of the S3 Glacier storage tier. But lifecycle rules allow you to automatically move objects that are not frequently being accessed or updated in your S3 bucket to a colder storage tier, so that you're not spending the full standard S3 rate on those particular objects. And there's some really useful features in lifecycle rules that allow you to specify exactly which objects you want to target. So sometimes you might have an S3 bucket where you have lots of data for lots of different applications, but there's only one particular application's data in that bucket that you want to apply a lifecycle rule to. And there's a couple of different mechanisms in the lifecycle rules feature that allows you to accomplish that targeting. So we'll take a look at how that works. There's also expiration actions. So once an object reaches a particular age, so if I create a object today, right now, I could say after 30 days, then I want to expire that object and actually remove it from my S3 bucket. And for versioned buckets, where you can actually have multiple versions of a key with the same name, then you can actually specify that you want to remove older versions that are not the current or latest version of that particular object as well. So there's a lot of customizability. It does get a little bit more confusing when you have multiple object versions, just based on how delete markers work. So I'd encourage you to read up on how delete markers work in S3. Basically, if you have a version controlled S3 bucket and you have an object in that bucket, and then you choose to delete that object, the object doesn't actually get deleted from the bucket. What happens is that S3 will actually create a new version of that key, but the latest version of that key will actually be what's called a delete marker, rather than actually storing the object data. So then what you can do is remove the older versions of that object, and that is actually going to remove the object data from the bucket. So you can expire non-current versions. And so if you have deleted objects, then it will retain the delete marker because that's going to be the latest version. But then you can actually choose to delete the historical versions of the object as well. So there's the ability to transition objects from hot storage to colder storage that's less frequently accessed, or you can simply expire objects. And if you're using a non-versioned bucket, that will actually delete the object from the bucket. But in the case of versioned buckets, that's where you have that delete marker that gets added when you actually delete an object. So just be aware of how delete markers work when you're dealing with versioned buckets. And we will take a look at that in an example here. So for transitioning objects, you can move to, again, these different storage tiers here. So this is standard infrequent access. There's also an intelligent storage tier as well that allows the S3 service to kind of automate the process of identifying which storage tier to place it in. So that's an option as well. This article here just kind of talks about how the whole process works right here. There's also a document here that talks about expiring objects. As we mentioned, if you have a version enabled bucket, then there is a difference in behavior in how this works. It does expire these things called delete markers here, or I should say it expires previous versions of an object rather than the delete marker itself. And then there is a bunch of other documentation here that is kind of interesting. One of them talks about how to configure S3 lifecycle event notifications. And if you're familiar with like S3 and using it with other services like Lambda, you can actually trigger certain things to happen anytime that a new object or a new file is uploaded into an Amazon S3 bucket. So you can kick off a Lambda function to process that new data that has been uploaded into an Amazon S3 bucket. You can also choose to just put a message onto an SQS queue so that you could have some other application running pretty much anywhere just pick up that message off the queue whenever it's ready and has capacity to do that. And then it can go read the object from S3. But this is the data structure that would get sent to one of those services. So it would send it to an SQS queue and it would look like this. So it knows what bucket and specifically what object key was actually affected here. And so that way your application says, okay, based on this SQS message, I can see that this key was added into this bucket in this location. So I need to go out and get that object and then process that data. But what's really interesting here is that when you're using the lifecycle rules feature of S3 buckets, you actually get notifications when one of these transition or expiration events occurs. So if a lifecycle policy executes on the back end and you have a whole bunch of objects that are, let's say, older than 30 days, and your lifecycle rule is set to delete those objects after 30 days, then the lifecycle rule will actually send these notifications to your destination of choice, and then you can trigger automation events and maybe log it to a database somewhere or send out an email notification or send a Slack notification just so that you have some kind of real-time log of what's going on inside of your S3 buckets. And it's not just happening behind the scenes and you're not really having any log of what's happening there. So by integrating with these event notifications here, you can really just kind of customize how you want to log those events happening, and you can trigger other types of actions based on those as well. So we're not actually going to enable this particular feature, but I did want you to be aware that in addition to the standard not life cycle, but the standard events that you have in S3, like put object or delete object and anything that supports events, if you choose to enable lifecycle rules, you do have the option to get additional events based on any time that the lifecycle rule is taking action on your S3 objects. All right, so what we are going to do is actually go into the console and create an S3 bucket. We'll enable versioning on it. We'll put some data into it, and we'll take a look at how to actually create a lifecycle rule. And I did want to actually show you how the versioning works, just so that you have an understanding of how the delete marker works. But what we also are able to do here is to add filters to lifecycle rules. And this article talks about it here. So once we get into the console and actually start talking about that, if you have any questions on how that works further, then feel free to check this out. But what you can actually do is within a given bucket, so we're just going to be operating in a single bucket. And again, if you have multiple applications that are storing data in that single bucket, which may or may not be a good practice depending on your preferences. But what you can do is create a lifecycle rule that targets a specific key prefix. So one application, let's just call it app number 1, is going to, maybe write data into S3 using app01's prefix. So you know that any object in S3 that has that app01 prefix on it belongs to that particular application, and so on and so forth for applications 2, 3, 4, 5, etc. And so that is one mechanism that you can use to kind of segment your data or classify your data based on which application actually owns that data inside of the bucket. And so that way, if there is one specific application component that's storing data in S3 that you want to apply a lifecycle rule to, then you could identify that segment or that partition of data based off of the key prefix. The other option that you have to filter which objects the lifecycle rule applies to is by using S3 object tags. So just like various AWS cloud resources can have tags configured on them, like EC2 instances or VPCs or subnets or security groups, or pretty much any type of resource supports a tagging strategy so that you can identify metadata, like, what team at my company owns this resource, or, when was this resource created, or, what's the source code repository for my infrastructure as code that is responsible for managing this particular resource, right? There's a lot of common use cases for resource tags like that. But Resource tags also apply to individual objects or individual files inside of S3. So if you are using macOS, for example, you might be familiar with macOS's file system capability that allows you to assign tags to individual files. And then you can actually go search for those files based on the file tags. Unfortunately, Windows 11 does not have a similar capability to that, but that type of tag metadata is incredibly useful to identify different metadata about the file. So like, again, when was this created, or what team owns this particular file, or what application or microservice owns this particular data. There's a lot of different ways that you can implement tags. But again, you could use that tagging strategy to kind of partition your data in S3, not from a structural perspective, but from a logical perspective, where you need to apply a lifecycle rule to a subset of data within a given bucket. You can use those object tags to target a lifecycle rule at them. So that's a really nice capability as well. And then there's also a minimum or maximum object size here. So if you want to target a lifecycle rule based on object size, then you are welcome to do that as well. Okay, so let's switch over to the AWS Management Console, and we are going to start by going to the Amazon S3 service, and we'll just start by creating a brand new S3 bucket here. It doesn't really matter what region you create it in. I'm just going to create one here called Trevor SG Lifecycle-video. And we are going to enable the bucket versioning feature here because I did want to show you how the delete markers work when you're dealing with buckets that have bucket versioning enabled. Okay, so we'll create that bucket. And I just added an owner tag there just because in this development account that's shared, my teammates need to know who owns that particular bucket. Okay, so then we'll go ahead and filter for lifecycle here, and this is the bucket that I just created. All right, so in order to configure a lifecycle rule, you will go under management here, and under management, you have lifecycle configuration. By default, brand new S3 buckets are not going to have any lifecycle rules configured on them. So you can simply hit create lifecycle rule, and I'll just call this Trevor01. And then by default, it's going to ask you if you want to limit the scope of the lifecycle rule by filtering. And so this is where we have the option to specify object size, object tags, as well as the key prefix. You can also just choose to apply the lifecycle rule to every single object in that bucket. And it does pop up this warning here. It says, hey, just so you know, this is going to apply to every single object in this bucket. Are you sure that that's what you want to do? So they do make you check an additional box there. But then down here, these are the specific actions that you can implement as part of the lifecycle rule. So something that might be really simple would be, hey, I want to maybe permanently delete non-current versions of objects, right? So if somebody deletes an object and it leaves a delete marker behind, that delete marker is going to be the latest version of an object. So I want to delete the older versions of that object prior to the delete marker. And so what you could say is basically if it's more than 30 days, and those objects are non-current after that 30 days, then go ahead and delete them. However, there is an optional exception to that where you can maintain a specific number of versions. So you could say, well, if an object gets deleted, then I want the delete marker to be retained. That's going to be the latest version of the object. Plus, I also want to maintain one version of that object as well. So that's an option that you have right there. You can also do things like expire current versions of objects. And again, if the bucket is not version enabled, then this is going to expire the actual object itself because there's only ever one version of an object in a non-versioned bucket. There's also a very useful lifecycle policy here that will delete what's called incomplete multi-part uploads. So if somebody is uploading a very large file, let's say maybe a 50 gigabyte file, maybe it's an operating system image or something like that, some massive file, and for some reason the file upload fails to complete, then you'll have what's called an incomplete multi-part upload. And so basically that's a kind of a hidden object behind the scenes that will cost you money. but it's not really obvious that that multi-part upload is there when you're actually listing objects using the, get object API, or if you are just looking at it inside of the console, it's not really going to be obvious that you have incomplete multi-part uploads. So it's a good idea just to apply the incomplete multi-part upload cleanup rule here so that you can delete those and say, hey, if there's an incomplete upload and it hasn't finished for 3 days, then obviously that upload is probably never going to complete. So we are just going to go ahead and delete it. So that's a good policy to have, especially on any buckets where you know that you're uploading data from maybe third-party sources that are not necessarily reliable. Think like SFTP servers or FTP servers that you might have third parties connecting to upload data to ingest. Maybe they're uploading really large video files or something of that nature. That's a really good idea to have incomplete multi-parts deleted after a period of time, just to avoid a lot of accumulation of incomplete uploads that cost you money but aren't actually giving you any business value because you're not really able to do anything with that data. So that's a good policy to apply as well. And then up here, there is transition current versions of objects between storage classes as well as non-current versions. So if we want to make sure that any older versions of objects, any non-current versions of objects for a version-controlled bucket are getting moved to a colder storage tier because we're only generally dealing with our latest version of our object, then this is a great option here. And so then you can choose, okay, well, which of the storage tiers or classes do I want to move it to? So if it's older than, let's say, 30 days, well, then maybe I will move it to standard infrequent access. And I always want to make sure I maintain at least one version. I could add another tier and say, well, if it's older than 60 days, then I want to move it to intelligent tiering. And again, I have the option to retain a certain number of versions here. So this allows you a lot of control over which storage class those older non-current object versions are getting moved to. And it's up to you how many of those you want to actually implement here. Okay, so I wanted to kind of show you some of the scoping rules here from a prefix perspective as well as from an object tagging perspective. So to do that, we're going to actually add in some data into this bucket here. So let me copy the bucket name here really quick. And then I'm going to, actually, let me do copy here. And then what we're going to do is fire up the AWS Cloud Shell here, and then you can run PowerShell with PWSH. And we're just going to generate some random data here. So I'm going to say 1 to 10, and we're going to say set content. This will create a brand new text file. And then the file is going to be, let's say, app01 dash, and then we'll create a placeholder, and then say new GUID.GUID. And then the value of the file will just be another random GUID. And then we'll close that off with a closing curly brace. All right, so now if I say get child item path app01 star, you can see that I've got a bunch of randomly named files here. I meant to put a TXT file extension on there, but I forgot to, but that doesn't really matter. We don't necessarily need a file extension. So now what we're going to do is generate another set of files for a different prefix, and we're going to call that app19. Okay. And then, so now if we do a get child item on app19, you can see that we have an additional set of files here. So now I'm going to upload both of those file sets up into the S3 bucket that we created. So I'll say get child item for app19 or app01 star. That should give me all of them. And then we will say for each of these, we'll say write S3 object into bucket, paste in the bucket name, and then we will specify the local file path is going to be the current item dot full name. That's the full file system path. And I can't remember if we need to specify a key or not. So let's just try that. And it looks like that is working there. So we're going to upload those 20 items into the bucket. And now if we do get S3 object for that bucket, you can see that we've got all these objects. And then if we pipe that into measure object, you can see that we have 20 objects in that bucket. We could also just say get S3 object, and then we could grab just the key and last modified. So we could say format table dash property key and last modified. And so as you can see, we've got a whole bunch of app01 files or objects, and then a whole bunch of app19 objects as well. So now what we want to do is to create a lifecycle rule that only targets the objects that belong to app number 19. So to do that, we'll just come up to our lifecycle rule here. We'll say limit the scope of this rule using one or more filters. And for the prefix here, all we have to do is say app19. And so for this rule here, I'll call this Trevor-app19 prefix. And then for that particular application, we'll say that we want to permanently delete non-current versions of objects after 60 days. So we'll hit create rule there. So now we've got a brand new lifecycle rule, and it is scoped, it's filtered to a subset of objects in the bucket, and only for non-current versions. So right now we only have current versions because we have not overwritten these objects with newer versions of them yet. So this policy or this lifecycle rule is only going to permanently delete any older versions. So at the moment, it's not going to have any effect because we only have current versions here. But if we were to overwrite any of these objects with a newer version of the object, which includes deleting them with a delete marker, then that is going to potentially delete these objects out of the bucket. So you might be asking yourself, well, how do I see if I have historical versions or non-current versions of objects in the bucket? Well, there's a command you can use in Cloud Shell here called get S3 version. And so there's a different API. So normally you'd use get S3 object to list the objects in the bucket like we just did right up here. But if you run get S3 version, that is going to show you the historical versions of objects for that particular bucket. So let's go ahead and paste in that bucket. And this is going to return this object as a result, but this object has a child property called versions. And that versions child property is what actually has all the metadata for the historical versions of the objects that are inside of this bucket. So what we're going to do is say, let's assign the result here to a variable like version info, for example. So now we have that object in version info, and then we'll do version info dot versions. And let's do dot versions there. And as you can see, we have this property that says is latest, and it's set to true, 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 true. And again, that's because we do not have any historical versions here. We only have the latest versions because we have not overwritten any of these objects yet. So as you can see, all of these keys have the latest version here. Also, when you version enable a bucket, you have a version ID specifier here. So if you ever need to operate on a specific version of a key, like a previous version, like maybe 3 or 4 versions old, there's a random identifier here called version ID. And so you can actually operate on those specific historical versions if you need to, using that version ID field. All right, so let's go ahead and overwrite this data with some new data, and we'll take a look at how the new versions actually get created. So what we're going to do is to grab the app19 files, and we are going to overwrite them with new data. So I'll say get child item dash path, and we'll say app19 star. So again, that's going to give us these files that are on the local file system of the Cloud Shell instance here. And for each of these, we are going to update the content or the payload of the file. So we'll say set content dash path, and then we'll just grab the current name of the file, which is _.full name. And then we will say dash value. We're going to use new GUID dot GUID. Okay. So what that's going to do is it's going to update the contents of each of those files prefixed with app19 with brand new information right here. Okay, so once we've done that, then we're going to re-upload those files to the S3 bucket. So let me just hit the up arrow here a few times. And this command here is going to do the upload, and it's going to replace the objects with the new versions of these app19 files here. All right, so now we're going to use the version command, get S3 version, to get all the object versions from this bucket once again, and we're going to update this variable called version info. And so if we do version info dot versions right there, now you can see that under the is latest column right here, you can see that a lot of these are false. So we have duplicate keys. So we have app19, 153 EEA, etc. And we have that duplicated here twice. One of them is set to true because you can only ever have one version that's the latest, right? It wouldn't make sense logically to have two latest versions of the same key. But you can see that for all of the app19 objects here, one is the latest version and one is not the latest version, or not the non-current version. However, for the app01 prefix here, we did not replace any of those objects with newer versions. So for the app01 data, all of the keys are the latest version because we never uploaded a new version of them. Now, this also applies to deleting an object, right? So let's pick one of these objects like this one down here. So we'll grab the key for this object, and then we're actually going to delete this object from the bucket. And so what we'll do, actually, before I do that, I want to show you there is another column that's not actually being displayed here. So let's do version info.versions and then say format table dash auto size dash property. And then let's grab the key, the last modified, the version ID. And then there's actually another column here called is delete marker. And we'll say is delete marker, and we'll also say is latest because we also want to see if it's the latest. Okay, so let me hide my video here so we can get a full picture of the data right here. So as you can see, we are just printing out the key, the last modified, the version ID, and if it's a delete marker or not, and if it's latest or not. And so again, for all the app01, none of those are delete markers because we haven't deleted any of them. And all of them are the latest version because we have never overwritten any of them either. For app19, however, you can see that all of them are not delete markers. All of them are false. However, we have the is latest for only half of them because we overwrote all of those app19 files, right? But I just wanted to show you that the is delete marker is currently false for all of these objects because we have not yet deleted any of these objects. So I'm just going to pick one of these objects to delete right here. So let's pick this key. And so we'll do remove S3 object. We'll specify our bucket name right here. We'll specify the key as well. And so now you can see that we have deleted it, and it gave us a new object version. So for the key that we specified right here that we just deleted, it gave us a new version ID specifier, and that is going to represent a delete marker. So now we want to refresh our version information once again. So we're going to do get S3 version, specify our bucket name, and we're going to repopulate this variable with fresh data once again. So now if we do version info dot versions, and let's actually pipe it into that command to do format table and just grab certain properties here. So now you can see for this one object ID ending in BE22, you can see that we have the original object version down here. That's the oldest one, looking at the timestamp here. Then we have a slightly newer one here. And now we have a third one. And this is the latest version because it says true in the far right column here. However, look what's different for this particular specifier here, 0JZ capital CE. If we scroll up a little bit and look at the output from the deletion command that we had earlier, it looks like that actually got cleared out of my buffer. But in any case, this version ID right here should have matched the version ID that we just saw got printed out when we deleted or removed this specific key from the bucket. So what happened is that the key did not actually get deleted from the bucket. What actually happened is a new version of the same key was created with a new version ID that's randomly generated by the service. But now that new version ID or specifier now has a property of isDeleteMarker set to true. So out of all these entries, all these different versions of the different keys that we have, all of them are false for isDeleteMarker, except for the specific key version that we specifically deleted from a bucket. So this is really interesting information just generally about how the S3 object versioning works, because again, when you delete or remove an object from an S3 bucket for a version-controlled bucket that has bucket versioning enabled on it, you don't actually delete the data. You actually are creating a new version of the object, but it is designated as a delete marker instead. So with this information in mind now, again, looking at just this one key down here where we have 3 different versions of it, the lifecycle rule that we created right up here, this is only applying to anything prefixed by app19. And the only action that we have configured is based on non-current versions. So for any non-current versions older than 60 days, we are going to permanently delete those non-current versions. So what that means is that the 2 non-current versions of this object right here are what actually contain the data for that object, right? So if we were to read this specific version of this object, we would see the original GUID. Then after we overwrote the data with new GUIDs, this object version here would represent that new GUID in the file contents. And now this third one is not actually containing any data because it's a delete marker. The delete marker doesn't actually contain any data itself. You're only being billed based on the actual key name, not the actual contents or payload of this delete marker. So what would happen is that that S3 lifecycle policy would apply to these 2 versions of this object, but it would not apply to the delete marker because that is the latest version of this particular object. So I know that can be a little bit confusing, but for this particular lifecycle policy action that operates on non-current versions, when you're dealing with things like delete markers, it's only going to apply to the older versions that are not delete markers if you have deleted an object from the S3 bucket. All right, so that is how we can use an S3 prefix to apply to only a segment of our data. So we have one application, app01, that's writing data with its own app01 prefix. That's not going to be affected by this because we limited it to app19. So we could have lots of different applications, and as long as they have their own unique prefix in the object key, then we can ensure that they're not going to be affected by these lifecycle rules. And we can apply different lifecycle rules on the same bucket for different applications because of that prefixing mechanism. All right, so let's go back to lifecycle configuration here on our bucket, and then we'll say create lifecycle rule again. And this time we are going to do something a little bit different. We are actually going to target or scope or filter, depending on what term you prefer, we're going to filter this lifecycle rule to only apply to objects that have a specific tag on them. And I'll show you how we can actually put a tag onto an S3 object when we create one. So for lifecycle rule name here, I'm going to call this Trevor-app01-tag-finance. And then what we're going to do is specify a prefix here. We're going to say this only applies to app01. Okay, because in the name here, we're going to say it only applies to app01. So we want to make sure we have that prefix, still partitioning it just to app01 objects. But we're also going to add object tags here. So we only want this lifecycle rule to apply to objects that have a specific tag. And the tag I'm going to use here is department and then finance. Okay, so any S3 objects inside of this specific bucket that have this specific prefix on them, that have this specific tag key value pair, are going to be affected by this lifecycle rule. So if it's finance related data and it's for app01, then we are going to transition the non-current versions, or actually, let's say permanently delete non-current versions. We'll say we only want to retain the current version. So after 90 days, we're going to delete any non-current versions because finance will just say they only want to deal with the latest versions of objects. They don't care about any, version history as long as it's older than 90 days. So what we'll do here is go ahead and just create this rule here. However, our S3 bucket here does not currently have any S3 objects with tags. So right now, that S3 lifecycle rule that we just created for department equals finance, that's not going to apply to any of the objects inside of our bucket. So let me hit refresh here, and you can see we have 19 objects in our bucket. Remember, we had 10 objects for app01. We had 10 objects for app19. However, we deleted one of the objects for app19 with a specific key. So even though that delete marker is still in place, technically, if you're looking at the raw data using the version API, if you actually look at the get object API and just list the objects in the bucket, that delete marker is going to be invisible, so to speak, from the get object API, or listing out the objects. So that's why we only see 19 objects here. So what I'm going to do is create another subset of items. We're going to generate some new data inside of the bucket that has tags so that it will represent data for finance, department equals finance, for the application app01. All right, so let's open up our Cloud Shell here again. And if we do a get command, so this is in PowerShell, we can say get command, anything with S3 tag in the name, because I can never seem to remember the actual tags. We have this command here called write S3 object tag set. And so what this allows us to do is to apply tags to S3 objects. Also, if you take a look at the write S3 object command here, you actually have this tag set parameter. And what you can do is specify a key like department and then a value like finance. And then when we upload a file up into S3, then it's going to have that department equals finance tag on it. So what we'll do is specify our bucket name right here and paste that in. And then we'll specify a key. So we'll call this app01-finance01.txt. And the contents of that file will just be hello from finance. Okay, so we just created a 20th object inside of the S3 bucket, and it only has one version because we only ever wrote to this key app01-finance01.txt. We only ever wrote to that one time. All right, so let's come back to S3 here and do a refresh, and now you can see that we have 20 objects, again, because we just added that new file. And so let's take a look for that file. Here it is, app01finance. It has a TXT file extension on it, and it has a 19-byte payload, which is the text that we entered right here in Cloud Shell. And let's see if the tags are shown right here. So right here, down here, we have tags, and it says department equals finance. Awesome. So now there is one object inside of this bucket that our brand new lifecycle rule is going to apply to. So if we come back to management and take a look at our lifecycle configuration right here and take a look at the brand new lifecycle rule, Trevor app01, tag finance, that is limited to department finance and the prefix app01. Now, if we created another object for finance, but it belongs to app19, like this, if we say the prefix is app19-finance01.txt, Well, guess what? Even though that new object has department equals finance, the lifecycle rule right here is not going to apply to it because it has to also match the app01 prefix. And so this new app19 object that we just created is not going to be included in this particular lifecycle configuration. So that's how tags work. It allows you to very granularly identify which objects inside of a given S3 bucket you want to target by specifying the key value pairs. So very powerful stuff there. And then the third and final type of filter is, of course, just the object size right here. So you can say, I only want this to apply to any files that are, larger than 1 gigabyte. That's the minimum file size it'll apply to. You could also say, I only want to apply it to objects that are smaller than maybe 10 gigabytes. So any files that are larger than 10 gigabytes, this is not going to apply to. So these filters are really there based on your specific business requirements. There's not really anybody that can, prescribe these to you. You have to kind of think about, as a business, how much data do we want to store? Do we need 90 days of data? Do we need 3 years of data? What are the size of our objects that we're dealing with? Is there a way that we could clean up data based on the object size? Maybe you're using it kind of like a downloads folder, and so some larger file downloads, you just want to clean those out. So you say, hey, anything that's bigger than a gigabyte, delete that, but we want to maintain the rest of the history, right? That might be a requirement. So that could be an option here as well. So it's really up to you to kind of use these different scoping mechanisms the way that you want to, as well as the actions down here. So just think about, based on what criteria do we want to move current versions of objects into a colder storage tier, lower priced storage tier? Or, how many older versions of objects do we want to keep around in hot storage before we move it to cold storage, right? And so we could say, well, we want to maintain 3 versions so that we're not, hamstrung in case we need to restore a slightly older version up to 3 versions old. So there's a lot of customizability in how these lifecycle rule configurations work. But if you're not using lifecycle configurations on S3 at all, then there's probably a good chance that you can save a fair bit of money by implementing creative lifecycle rules. But again, it's going to be based on a per application basis and unique business requirements that each of your departments is going to have. So make sure that you meet with your team, talk through the requirements. If you are storing data in S3, think about, what's the nature of the data in S3? Is it binary data? Is it text data that you could potentially process with an Amazon Athena query to get a better understanding of? Do you have a good tagging strategy in place? If not, can you do that moving forward and maybe retroactively go back and apply a tagging strategy so that you can more intelligently and more granularly apply these lifecycle configurations to your S3 buckets? Those are just some things you want to think about as you are dealing with lifecycle configurations. But again, lifecycle configurations on S3 can save you a substantial amount of money, especially if you're spending a lot of money on Amazon S3 and storing very large amounts of data in the S3 service. So in any case, if you are interested in having StratusGrid help you out with cost optimization, feel free to reach out to us. Again, our website is over at stratusgrid.com, and we would also love to walk you through our Stratosphere platform here. Again, my name is Trevor Sullivan, Solutions Architect with StratusGrid and AWS Ambassador. Please leave a like on this video if you learned anything new, or you could also subscribe to our channel so you get notified about future videos. You can also go back and watch all of our other videos as well. We have a lot of very interesting videos on things like Amazon Bedrock and a lot of fun topics like that. So feel free to check those out. And also please leave a comment and let us know what you thought of this video and let us know what you learned from it. Thanks so much, and we'll see you in the next video. Take care.